Today we're going to talk about generators. A generator is a function that returns an iterator that produces a sequence of values when iterated over. Generators are useful when you want to produce a large sequence of values, but we don't want to store all of them in memory at once. So let's define a function and turn it into a generator. Okay, so here I've defined a function called numbers, and I've set it up in an infinite loop, and it's going to return the numbers, and then it's going to increment num by 1. However, it's complaining here, okay, and we'll see why in a minute. So let's run that and see what we get. Okay, so it returns the value of 0 because num is assigned to 0, goes in the while true, and it returns the num of 0, and then it exits and stops. Okay, so it's not exactly what we want. How do we turn this numbers function into a generator? Well, it's very simple. You change the return keyword into a yield keyword. Okay, now it will yield a number. So let's run this again. And you'll see now it prints out you have a generator object. So how do we get the numbers out of this generator? You use the next function. Okay, now let's call the individual numbers from the generator using the next function. Okay, first we have to assign the generator to a variable. Okay, so you can see there it's showing you the generator object. See it there. And then it returns each value as it goes next through the generator. As you'll see, it comes in here, it goes through infinite loop, it yields a number, and then it stops and it waits, okay, until it is called again. Then it adds 1 to the number, and it goes around the loop, and it yields the next one. But it always remembers where it was. Okay, this is called state. Now let's iterate over the generator using a for loop. The numbers will continue forever, and it's not storing them in memory. Okay, so what I'm going to do is I'm just going to comment out this code here, as we don't need it anymore. Okay, so I'm going to run that. As you can see, there's the numbers coming out of my generator, and they get very large very quickly. Okay, so you can break that or Control C. I'm just going to stop it here, and it will break. Okay. Okay, so now I'm going to compare a generator to a list, and I'm going to show you the memory footprint of each, and you can compare to see what the difference is. And I'll also show you the performance. Okay, so first we need import sys and cprofile. Okay, so here I have set up a squares underscore g, just so that I can determine that it is a generator, and it's using a generator expression. As you can see, it's very similar to a list comprehension. Okay, and here I have a list comprehension, and from the code you can see it's going to basically take I in a range to 1000, and it's going to square each one. Okay, same with the list. However, the generator is not going to be stored in memory, but the list is going to calculate all these values and store it in this object in memory. So to get the values for the generator, I have to iterate over them. So I'm going to use a for loop for that. And then I'm going to display the list. Okay, so as you can see, they are exactly the same. Just goes up to 1000. The range goes up to 1000, and there's all your values. The top one is the generator, the bottom one is the list. Now let's show you what the memory footprint looks like. Okay, so there you can see there's the generator in memory, and there is the list in memory. Okay, now if I increase this value here to make it actually bigger, let's put an extra 0 on there, and there, you'll see the generator will stay the same, but the memory consumption for the list will go up. Okay, so let's run that again. As you can see, it went up dramatically, but that stayed the same. Okay, now let's compare the performance. Okay, so to get the performance, I'm using cprofile.run. So let's run that, and it'll give me performance figures. Okay, so this is the top one is the generator. As you can see, it has parenthesis where the list comprehension has square brackets. Okay, so that is the generator, and this is the list comprehension. And you can see the list comprehension is probably about twice as fast. You can see 0.007. This is 0.014. So the generator is definitely slower at generating the numbers. Okay, so now I'm going to give you a practical use case where you might want to use it. I'm going to show you some code for a numbers palindrome. So a palindrome is where a string or number reversed is exactly the same. Okay, that's called a palindrome. So I'm going to make a palindrome that's going to return the numbers that are the same backwards and forwards. Okay. IsPalindrome is a function and it reverses the number that is passed in, and it checks the number. If it's equal to the reverse number, then it returns the number. Otherwise, it returns false. Don't worry too much about the maths. It's quite complicated. I'm not going to get my head around it. Okay, so here is my generator function. Okay, and then I'm going to step through that generator and pass the numbers to the isPalindrome function, and it's going to print them out for me. Okay, so it's going to step through the infinite sequence of numbers. It's going to pass the number into the isPalindrome. It's going to reverse it, compare them, and return the number if it's the same. Okay, so let's run that. Okay, so there you go. So let's stop that. Alright, so you can see the number is exactly the same whether you read it either way, and that's a numbers palindrome. Right guys, that's today's tutorial on generators. I hope you enjoyed it. Cheers.